So we're now going to get into the range of a function, and this will be the last part of 2.1, and we're going to do two examples. We're going to consider the function the absolute value of x plus 1, and then we're going to consider the square root of x. Before we dive into these, it's probably good to first state what is the domain, what is the range of a function. So the range of a function f of x, what is it? By definition, it's all the y values that you get when you plug in every x value in the domain. So it's all y, where y is f of some x, where x is an element of the domain of f. So as x runs through the domain of f, you'll get a bunch of f of x's, which are a bunch of y values. The collection of those y values is the range of f. So let's look at example A in this particular page. And a lot of times this is an important item, we use the graph of f of x to determine its range. It's not always the case that you have to do that. It's algebraically, once you get comfortable, you can probably do a lot of them algebraically, but it can be challenging. It can be easier to actually just visualize it. So let's draw the graph. So let's start with doing the domain of f of x, where again f of x is the absolute value of x plus 1. The domain of f, well, you can take the absolute value of anything, so it's just everything, negative infinity to positive infinity. So what we're going to do is we're going to make a little chart of x, y values just to start, and then we'll get the graph out of that. So 0 goes to 1, because we have 0 plus 1. Negative 1, we get absolute value of negative 1 plus 1, which is 2. For positive 1, we get the same thing. For negative 2, you'll have the absolute value of negative 2 plus 1, which is 3. For positive 2, you'll get 2 plus 1, which is also 3. So let's take those points, graph those, and then see what the range looks like. So 0, 1, and then 1, 2, negative 1, 2, 2, 3, negative 2, 3. So we get this. It's the same V shape as just the absolute value of x, except it's bumped up by 1 unit. Okay, so this is the graph of f of x. This is the x-axis, this is the y-axis. And now you say, okay, well, what y values are actually hit? Well, clearly these values right here are part of the range, right? 1, 2, and 3, because those are the y values that correspond to some x value. It may be multiple x values, it may be just one x value that corresponds to it. In this case, each of them has 2 x values. Another way of visualizing this is to say, okay, if I drew the line y equals 2, this crosses the graph. And the fact that it crosses the graph means y equals 2 is actually part of the range. So just to list, I'm not going to first write off the full range just yet, but you can 1, 2, 3, right? The line y equals 1 also crosses the graph right at that base point right there. Or any point in between also, like if I put in, 2.5, that would cross the x-axis, or that would cross the graph. So if you want to collect all of them, well, visually you can see if y is bigger than 1, then the corresponding line crosses the graph. So corresponding horizontal line, whether it be 2.5 or 3 or, you know, the square root of 58 or a bunch of, you know, anything you have above 1, if you draw a line there, it'll cross the graph. And so the range is exactly that. So the range of f is everything beyond 1, or simply y greater than or equal to 1, if you want to think of it as an inequality. So that's the range. It's because everything above 1 is hit, and everything below you can just, if you say y equals a half here, that line doesn't cross the graph. So y equals a half would not be part of the range. There's no way to get a half out when you're taking the absolute value of x plus 1. So that's the range of this particular problem. It's the, again, the y values that correspond to plugging in every x value. Okay, let's do the second example, and then I'll leave you with some exercises to try. So the second example was the square root of x. And this is another graph that's going to be important. The absolute value of x, the square root of x, is also an important graph. So let's first, we'll do the domain, and then we'll do the graph. Well, what is the domain here? We need x to be positive, because we need any square root. You can only take square root of positive or non-negative numbers. So anything 0 or above would be acceptable. So that's the domain, because x, i.e. x, has to be at least 0. Let's put in a little table here of x and y values. And since we're only allowed to plug in positive values, let's plug in some nice values. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So for example, the range definitely has 0, 1, 2, and 3 in it. Let's see what else it has based on the graph here. So we have 0, 0, 1, 1, 2, 3, 4, 2, 5, 6, 7, 8, 9 right here, 9 and 3 somewhere up here. So the graph is something like this. Okay. So this is the graph of the function y equals the square root of x, or f of x equals the square root of x. And now we say, what is the range? Well, again, you can visually see that if I draw any horizontal line that's above the x-axis, as well as the x-axis itself. So for example, this is the line y equals 0. Maybe we have a third here, you know, whatever. All these values. So if y is at least 0, then the corresponding horizontal line will cross the graph. And no other values work, right? And if, in parentheses, if y is less than 0, it doesn't cross. And hence, so what you have is that the domain of this, the range of this function, the range of f is just 0 to positive infinity, and that's it. So let me leave you here with just a couple of exercises, because these are probably best done with practice. So let's take the function f of x is equal to x squared minus 1, and the function square root of x minus 2, and then plus 1 outside of the square root. So what you want to find is the domain, the range, and the graph for both of these. Okay, So I'll leave you with that, and this is also pretty much the end of 2.1. We'll start the next video with the solutions to these and then move into 2.2.